Hello and welcome to another CQPweb tutorial. This video is all about the special ways in which you can amend a standard query in order to search for more than one thing at one go. So, for instance, in the early tutorial videos, which you may have seen, I illustrated how you can search using CQPweb for a single word, using examples such as searching for the word however, or searching for the word elephant, or that sort of thing. However, what if you wanted to search for more than one thing? What if you wanted to search, for instance, for all the different forms of the word sing? Well, now, if you know anything about English word formation, then you'll probably know that sing is a verb which has an irregular past tense, which is sang, and an irregular past participle, which is sung. And then there is also an irregular inflection of a related noun, which is song. Okay, so all of these words are morphologically related, and what they have in common is the first, third and fourth letters, whereas the second letter changes. Now, it would be quite possible to do 4 different searches in CQPweb for each of those words to find out how frequent each one is in your corpus. And again, as in previous videos, I'm using the British English 2006 corpus as my example. However, there is a certain technique called wildcard searching where we can use a special character to indicate any character. What precisely we mean by anything, any character, varies depending on which wildcard character we use. This idea of wildcard searching should be moderately familiar because most web search engines and database search engines allow you to use wildcards, where you use a question mark or a star or something like that to indicate anything. And you may in fact be familiar with the term wildcard. Let's take a quick look at a basic wildcard in CQPweb and see how it works. One basic wildcard character is the question mark. The question mark represents any single character. So, if we put a question mark in the second position in this 4-letter word, then it will find words that have S followed by anything, any character at all, followed by N, followed by G. Okay, so it will only find words that have S, something, N, G, which indeed covers all of sing, sang, sung, and song. Let's take a look. Start query. And there you can see, as I was saying, lots of song, the occasional sing, one sang there. Do we have any sung? I can't see any sung. Ah, there's the song. Okay, so examples of all 4 there. So, that is a very basic example of a wildcard. Why do we call them wildcards? Well, it's a reference to games such as poker and other card games where certain cards are wild, and if a card is wild, then you can use it when you're putting together a hand to represent any other card. So if you don't have the 8 of clubs or whatever, then you can use a wild card instead to represent the 8 of clubs. So that's why we call them wild cards. The question mark is the most basic one. It represents, as I say, a single arbitrary character. There are more. There are 2 or 3 more that I'll introduce. One thing I will say before I go further is, first of all, that this link here to the simple query syntax help explains a lot more about the wildcards. And a second thing I will mention is that if you are familiar with the search language called regular expressions, then you'll recognize quite a lot of what these wildcards do. But if you want to use full regular expression syntax, then you need to use CQP syntax instead of simple query. Here I'm only going to talk about the wildcards in simple query, which give you access to some of what regular expressions does, but not all of it. And if you don't know what regular expressions are, please ignore everything I just said, and we'll get back to the wildcards. So, question mark, single, arbitrary character. Easy peasy. The next wildcard that I'll introduce is star. Star means anything, literally anything. It means 0 or more characters, 0 or more of any letter, in other words. So, for instance, if we use the star at the start of a word, and then we add some kind of suffix, then it will find all words that have that suffix. So if we ask for star-ing, we are saying find 0 or more characters followed by ing. So let's search for that. We should get sing again, because that's something followed by ing. Yes, there it is. We've also got something, then lots of verbs, obviously, because ing is a verb ending. Morning, anything, so on and so on and so forth. Lots of different things there. But one thing to remember, and it's perhaps not 100% obvious with ing, but let's take able for instance. Able is a word on its own. Okay, so if you search for star able, then we are searching for any word that ends in A-B-L-E, but we're also searching for this word on its own, because the star represents 0 or more of anything, and therefore if we've got just the word A-B-L-E, then that matches 0 of anything followed by A-B-L-E. So if I start that, okay, so yes, there we are. We've got able, where the star matches 0 characters at the start, but we've also got table, where it matches 1 character at the start, and then a whole lot of words that actually have got the suffix able: foreseeable, inconceivable, uninhabitable, capable, unsociable, so on and so on and so forth. Well, suppose you don't want the word able. Well, suppose you just want able as a suffix. Well, one way we can do that is to use a different wildcard, our third wildcard, which is plus. And plus represents 1 or more characters. Okay, so if question mark is 1 arbitrary character and star is 0 or more arbitrary characters, then plus is 1 or more arbitrary characters. So while this will match nothing or anything, this will not match with nothing. This has to match at least 1 character. But whereas compare question mark to plus, question mark always matches 1 and only 1. This matches 1, or it might match more. So let's rerun the able with plus able. Now this will get only words that have something, 1 or more characters here, followed by able. Let it hum away. So our concordance no longer has those examples of able in it. So we're looking at actual words where it's either able, as in enviable and unavailable, or where it's a word like enable, where it's not the suffix there, able is actually the root there. But we still have table, we still have a word where the able at the end isn't really a separate morpheme. Can we do anything to get rid of that? Well, yes, we can combine wildcards to specify a particular number. So, for instance, let us consider that if we are looking at something to which able or able can be attached to form, as a suffix or as a second element in a compound, then it's probably going to be 2 or more characters long. Okay, so in table, the able isn't a suffix because t on its own is not a morpheme. So how about we insist that it must be 2 letters at least before the able? How do we do that? Well, it's quite easy. We include a star. We include a question mark for the characters that we insist must be there. So let's say we want 2 as a minimum. Then a star for however many more there happen to be. Able. So this is at least 2 characters because we have to have at least 1 letter to match that question mark and 1 character to match that question mark. Then the star matches however much else there might happen to be. 0 to 10, 0 to 20, 0 to 30, however many characters there are. Doesn't matter. So we should no longer get table now. We should only get, yes, there we are. Enable is there still, but all the rest, able is actually an affix there. So we're getting a little bit closer. Now note that this is directly equivalent to this. Why is that? Well, this is 2 plus 0 or more. So 2 plus 0 or more equals 2 or more. What's this? Well, this is 1 plus 1 or more. 1 plus 1 or more equals 2 or more. Okay, and just to prove it, let's go, and this will give us enable and all the rest, but it won't give us table. Yeah, enable but no table. Okay, and again we can prove it if we wanted to by using by going up to 3. If we wanted to rule out enable, then we could say give me 3 or more, and that will work exactly the same. Doesn't matter whether we use this or whether we use 3 or more. 3, we can use that or we can use that. Either of them will work the same way. So let's go with the first one. Yes, and now enable has gone as well. So we really are only getting the ones here where it's some kind of suffix. Not to delve too deep into the etymology of these words, but that's what we're getting. So you can see the linguistic applications of these things. Now, one thing that is important to mention is that because we've introduced these characters as wildcards, we need to remember that these things will always be wildcards. Okay, so let's say you wanted to search for questions in the corpus. You can't just type in question mark because question mark is a wildcard. It will find any word that has, if you type in a question mark on its own, it will find any word, or punctuation mark because punctuation marks count as words in CQPweb. It will find any word or punctuation mark that is 1 character long. So this probably will include some question marks, real question marks, but it also includes lots, I can't find any question marks here, never mind, but it also includes lots of other punctuation marks. It includes the word a. There should be some examples of I somewhere around. Ah yes, there's one. A and I, yes, and an actual quotation question mark there. A and I, which are the 2 most frequent 1-letter words in English, plus loads of punctuation marks, which are a single character and therefore count as one-letter words. Okay, so if you want to search for questions in the corpus, you might want to search for the question mark, the actual question mark, not just anything that's one character long. How do you do it? Well, you do something called escaping. Escaping means that you signal that you really mean the actual literal character, not the wildcard. And it's done by putting a backslash before the character. So question mark is a wildcard. Backslash question mark means find me a question mark. So if I do start query, there, you can see that just finds question marks. So far, so easy. You just have to remember certain characters are wildcards, and if you use those wildcards and you actually want to search for the real thing, you need to escape it. Same with plus, same with star. So I don't know if there's many mathematical texts in this corpus. There might be, let's see. Are there any where we have the plus symbol on its own as a word? The actual plus symbol? Yes. So you can see exactly the same principle works. Now, do we have any with the star on its own as a word? Some corpora may have this in to represent the multiplication sign. But here it doesn't seem to be representing the multiplication sign. It seems to be being used for bullet points, and that's ended up as being stars in the texts of this corpus. But anyway, searching for that means using the escape, just as with the question mark, just as with the plus. Okay, so that's star, plus, and that's question mark, plus, and star. Three most important wildcards. The other thing we can do is we can create variable options within a word. Okay, so we don't just have to have use of these wildcards to specify anything. We can say find me one of a specific list of things that I have asked for. This can be used, for instance, to account for differences in spelling. If you want to search for a word ending in the suffix "-ize", then you'll quickly realise that this can be spelt in two ways in English. And contrary to popular myth, it's not a case that it's one spelling is American and one is British. They are both found in British and American English. Any difference is one of frequency, but these two suffixes are basically the same suffix, and this copies the Greek spelling and this copies the Latin spelling. And they're both used. So if you want to search for a word like realise, for instance, which I always spell like that because I like Latin, it's an interesting language, so I use the Latin spelling, then you'll miss any that are spelt like that. CQPweb's simple query syntax allows you to specify alternatives. So, if we've got really as the fixed bit at the start and e at the end as the fixed bit at the end, then we can specify a variable bit in the middle by using square brackets and then putting the two possibilities separated by commas. So what this means is that here you need to find either this or this. So let's take a look at that. Right, lots and lots of realise with an S, but also realise with a Z. There's one. There's another. There's another. Which illustrates what I was saying, that it's not the case that the spelling with the Z is American. It's the case that there is a frequency difference, but both variants are found in British English and both variants are found in American English. So this allows you to cope with spelling variation. I'll give you another example. Another example is that there are many words ending in OUR in British English, which end in OR in American English. Let's take colour as an example. how do we specify that there's a possible U there? Well, we can use the same syntax. We can say, give me options, square brackets. Well, the first option is that we have a U there, and the second option is that we have nothing there. So we just put nothing after the comma. And that will find colour spelt with a U, or colour spelt without the U. Let it hum away. So there we are. This is a British English corpus again, so it's not surprising that most of the examples are with U. Scroll down. Can we see any without the U? Not yet. How many pages of this are there? Oh, only 2 pages, so let's go to the next page and see if we can find one without the U. Ah! There's one. In a brand name, interestingly, HP Color Laserjet, which is the name of a type of printer, so perhaps that's why the American spelling is there. Oh, but there's one. There's one with the American spelling that's not in a brand name. Interesting. So that lets you do alternatives. As well as dealing with spelling variation, alternatives can also help you deal with morphological variation. So if we take a simple verb like walk, as well as searching for walk, if you're interested in the verb to walk, you might well be interested in all the different forms of it. You might be interested in walks as well, as in he walks, or walked, as in we have walked, or walking. You might be interested in all of these things. So the way to do this is simply to add on a set of options at the end. So walks, walked, walking. Note that the options between the commas do not have to be the same length. Right? They can be different lengths. As you see here, this is 1 character, this is 2 characters, this is 3. It doesn't matter as long as one of these things matches at this point in the search pattern. Yes. So we have walks, walked, walking, and we should have a 0 as well to allow for the 0. Right, so that gives us 4 possible options. If we start query, up it pops. And you can see we've got the different forms in the concordance there. We can also do the same thing with derivational morphology as well as inflection. So if we're interested in, to go back to one that we looked at before, if we're interested in the word capable, we might also be interested in the word capability. Again, it's easy enough. We just open up some brackets, not without a space, must never use a space there, and put in the bit that is variable, like that. We might also want to throw in the plural. We might want to say capabilities. So there we've got the adjective capable, the derived noun capability, and then the plural of that derived noun capabilities, all caught by this one search pattern. And there we are. The first 3 examples actually capture all 3, which is nice. So that's that. Having introduced the 3 wildcards and having introduced the use of comma-separated options, there is one very important thing that I need to point out, and that's that these wildcards and the comma-separated options, they only work within a single word. So for instance, if you're searching for a phrase and you want to search for example, this hat or that hat, you can't do this. That won't work, not at all. These alternatives can only operate within a single word. At the very most, you can have a whole word represented within these, the whole of a word, but you can never have a phrase within here. Right? So, for example, if I go this, that, There I'm saying give me the whole word, so that would work, for instance. But if I'd put a space, yes, you can see there I've got this or that. But if I'd put a space there, so for example this man, that woman, that query will not work. And when you do that, you will get a kind of fairly incomprehensible error message, and you will just not get the query. The query will not work at all. We'll discuss how to do alternatives for phrases in a separate tutorial. And that's all for now.